Hello. Good morning to you too. Yes, it is the Lego Star Wars Imperial Droid set. Yes. Yeah, I'm gonna make this. This is like I'm gonna start doing this design thing here. When Christmas time comes around, I'll put a little Christmas tree back there. It's Halloween. I'm not much, I'm a man, so I don't have many decorations around the house, but I've got a gas mask there. That's kind of my spooky. That's my attempt at that. Good morning, Uchu. Hello, Brandon. Yeah, he did know that off the dome. I was amazed. I've always been a Lego guy. My mom still buys them for me as little gifts, which I appreciate. Good morning. Good morning to you too. Yeah, we are off to a great start. It's going to be a good day. It's Friday Eve too. It is Friday Eve. Whoop. Had an X-Fighter Lego set a while back. I used to be really into Bionicles. I don't know if you guys know what those are. I think they're still around. I played with Bionicles for like my entire childhood. That was probably my toy of choice. I played with those for so long. Yeah, I agree. It's only 11:28 here, so we're just gonna dink around for a little bit, wait for people to get in here. Good morning, Hamma. Good to see you. Yeah, there was a show. There were video games. They had this like ad back in the day. I think they used Evanescence for like the song. That was like the beginning of my emo phase. It was a good time. All right, we'll get started here pretty soon. Putting the vibes out there. It's going to be a good connection day. Going to be a good connection day, hopefully. Good morning, Waffle. Welcome. As you guys say, hopefully Deborah doesn't crash us. All right. That didn't help at all. Welcome. Happy Friday Eve. It's Thursday, and we're going to continue on talking about virtuals from last class. Now, I did put up assignment 5. All right, it's up there. You can look at it. After today, you will be able to do it. All right, I have reviewed this one. Good morning, Nick. I have reviewed this one, and it should be a good one. I'm thinking back to assignments like assignment 1, assignment 4 maybe. I know you guys had a lot of fun with that one. Maybe those 2 assignments in particular have been the hardest. I'm thinking assignment 5 will be a little bit easier for you guys. But you are still working with pointers. So it's not so much the amount of coding you have to do. It's more understanding how the code is working, how the abstract functions are working. Or not abstract, but virtual functions rather. So I have it set to be due in 6 days, I think. 6 days. It shouldn't be an issue to get it done by then, but we will. I will keep my eyes out to see how we're doing with it. All right, it's a fun one, and if I have time at the end of class today, I'll go over it. This assignment was made by Professor Sam Black. There is a video in the Web Campus assignment. You can click play on that, and he goes over the whole assignment with you. So if I don't get to it at the end of today, there is a video that you can watch. Now, that being said, I have gone through that assignment, and I found that we're using vectors in there, and I don't think we went over vectors yet this year, so we're going to take 5 minutes to talk about them. They're very easy, okay? You don't have to worry about anything. They're super easy. But before we do that, I just want to also briefly mention, for those of you who did not see my chat in the Discord there, I was, kind of talking with some students, and assignment 1 went very poorly for a lot of us. Like I said, there was a lot of you who put in some great work for that, and I don't want to discredit that. But I do want to offer some opportunity to make up the grade for that assignment. So if you didn't see the final project that happens later this semester, if you get a higher percentage grade on that assignment, I will use that and replace it with your assignment 1 grade. If you already have 100% or 99% on assignment 1, that's like the least amount that you can get. So your grade will not go down at all. But if you maybe got 20% or whatever on that first assignment, and you get an 80% on the final project, I'll take that 80% and I'll put it over your assignment 1 grade. So I think that's fair. I hope you're okay with that. And I hope that's a little bit of an incentive to really do well on that final project when we get to it. So now that that's out of the way, there's 2 more things I need to talk about. One, you saw that your assignment 4 grades went up. You saw that the comprehension grades went up. You also saw your test grades went up. There was a curve for that. That being said, a lot of you might be, this might be a little bit of a wake-up call. Maybe we got to start coming to office hours more, getting started on assignments earlier, some stuff like that. There is early reporting going on, and I did submit those. So you might be receiving an email, depending on your current grade in the class, from, I don't know what department that is, but maybe from your advisor or something like that. So just be aware of those. And if you're worried about being able to pass this class, please come talk to me, and we'll see if we can work some stuff out here. Mail says, this is going to be a big one if he gave us over a week. Well, not really. I didn't expect anyone to start it yesterday, since we haven't finished it. It should be, I will give you 6 days, I guess, starting now. But that's that. So if there's no further questions about that, we're going to get started with vectors, okay? Now, some of you haven't used vectors before. And vectors, of course, are math. They're math structures. Right, yeah, so Chef says got lost on the vector fish list. So we're going to talk about that right now. So obviously we haven't done vectors before. Obviously it's a math structure, right? Calculus, linear algebra, I guess, stuff like that. So vectors are just kind of arrays, right? Obviously in math, this is not a math class, so I'm not going to talk about it, but it's kind of like an array, and in there you've got, say, some values. whatever, right? And vectors can have n dimensions, meaning they have one element, they can have 20 elements. All right? It's basically an array of n dimensions. Where n is any positive integer. So we're not doing calculus in this class. Why would we use a vector in C++? Well, for many of us, implementing a dynamic array class is a pain in the butt, right? We kind of did that last week maybe 2 weeks ago, with the string class, right? Where we have this pointer and we've got to delete it and reallocate, resize, all this stuff with this pointer. And you may be asking yourself, is there an easy way that I can just make sort of a dynamic array without having to make my own class that does all these pointers? Well, C++ includes this vector class, or the standard library. Standard template library includes a vector class. And simply put, this is an easy way to get a dynamic array of any type. Okay? So that's what we use vectors for. And that's what vectors are being used for in this class or in this assignment. So instead of having to make that huge class, we're just going to use a vector. So if you ever want to use a vector, and so you might ask, when do I need a dynamic array? Well, when you don't know how many elements are going to be in your array. Let's say you're working at some business and you process reports. And every day you end up with a CSV file that contains information about COVID. And you don't know how many lines are going to be in that CSV file, right? I may have used this example before. So if you've got some struct COVID data here, and whatever's in there is in there, right? I don't know what kind of stats we've got going on here with this COVID data. But if you've got this struct here, and you want to read in this Excel sheet, this CSV file, you want to make an array of this stuff. So are you going to, say, open that file every day and say, hey, this file contains 1,000 lines today. So I'll make my array to be 1,000. And then you read in the file, right? But then the next day you open that file, and now it's only got 678. So you got to open up your program. You got to change this, you got to recompile it, right? Next day comes, it's 10,000, you got to change it, right? You're getting my point here, hopefully. So we need a dynamic array. And instead of doing stuff with pointers, which we've been training to do, we can use a vector. Can you guys still hear me? No. Terrible. Oh, man. I jinxed it, guys. It's been jinxed. Yeah, you can see I've got Chrome open down there. It's not even 12. Yeah. All right, we're back. We're back. So we'll continue on here. So, as I was saying, we don't know how many elements we're going to have, so we want a dynamic array. So all we have to do is come up here and say, hey, give me a vector, please. The vector library. You say, now I'm going to make a vector for the COVID data. So vectors use something called a template. Now, if you check the syllabus, that's something we're going to go over here in a few weeks. All right. So vectors are classes. There's a vector class, rather. meaning you can declare vector objects. Del char. You can del char. In addition to this, vectors are templates, which means they can have any type. Okay. Now we're gonna get to templates in a little bit, right? In a few weeks, we'll talk about this. But that just means you have to specify the type whenever you declare it, just like anything else. Specify the type when declaring any object. So the syntax for that might look something like say vector, now whatever type it is, this type, my array. Like I said, you've never seen this before. Maybe you have, you know, if you did this in 135, but many of you haven't used vectors before. We have to specify the type. So if we want to make a type for our COVID data, we're going to say, hey, please give me a vector for the COVID data. Make sense? Now, at this point, this is like a constructor is called, right? Constructor is called. What else is going on in here? Well, it is empty, right? Size 0. Which means the pointer inside of it is probably null pointer. Well, I'm not sure. I didn't make that class, all right? So it's empty. So now we're going to want to add stuff to it. How do we put elements in there? Just kind of like with a string. How do we add characters on the end of that thing? So, that's a sneak peek of the assignment. Musical chair flashback. Oh no. Okay. How do we add elements into the vector? Well, very simply, we use something called push back, which can be kind of read as like push an element to the back of the array. All right, this push word, it comes from stacks and queues. All right, we use stacks and queues. We haven't talked about those yet, but you're going to see this push word a lot. So this means push an element to the back of the array. You can also use something called push front, I believe, which push an element to the front of the array. And then you can also do something like pop back, which will take out the last element and return it. And then you could probably also do something like pop front, though I'm not quite sure. I'll let you do the research on this one, but this one basically take out the first element and return it. All right, so I'll let you kind of do some stuff with that. It might be push, I'm not sure. For those of you who don't know, you can always Google something like vector C++. Okay? You can do this with anything. Now, obviously, you're looking probably for Stack Overflow because you're not super good at reading documentation or whatnot. It's fine. I was there too. But if you come to, say, this website here, you can actually see all of the stuff that it has. So let's kind of look through here. We're working with probably C++ 11. And it's got some member functions. It's got some constructors, destructors, operators. We're going to skip the iterators part. Now we've got some element access stuff and some modifiers. So you see you've got push back and pop back. You can click on those to see what they do. Then you can do an insert, I guess. All right. Well, I'm glad we looked at this. If you want to mess with this, you're welcome to. This class is not about learning how to use vectors. I could have sworn there's a push front and stuff like that. But maybe there's not. So I'm going to go ahead and delete that part. There's a pop back, though. I'll keep that one. Really, these are the only two things you need to know for the assignment. There's really only two things you need to do. Yeah, so let's look at that here. We're gonna stop this COVID data example, and we're gonna change it up. Let's make this, hey, this is for ints. All right. So how do we push elements into it? So right now, we're looking at an array that's like this. It's empty. Has nothing in it. Now we're going to put something in it. myArray.pushback 4. So now you get 4. All right, that's in the array. Chef, I'd use pushback. For assignment 5, I'd use pushback. I would use pushback for everything. Insert, I think, will put an element. It might try to put elements in between things. And pushback will just put it on the end. So this is probably the easiest function to use. So I would use pushback for assignment 5. So now let's say I call my array pushback again. 5. Where does that 5 go? Does it go in front of the 4 or behind the 4? Of course, we've got a little delay now, but that's fine. I can wait. It goes behind it, right? So now we've got 5. So then you keep calling pushback on it, and that's how you insert elements to the array. Now, if I want to iterate over it, that's the next and final thing we'll talk about here. If you want to iterate over it, I don't know. If you want to iterate over it, and access elements in it. So this is probably the easiest part. All right, think back to strings. To get the size of the vector, you do vector, I guess my vector dot size. Now this returns an unsigned integer. All right, that's what it returns. The unsigned part means that it's positive, right? You can't have a negative size in a vector. So that's what this is. You'll probably see it as a size t, which is just an unsigned integer. Thanks, C++. All right. And then how to get elements out of it. How to access elements, rather. Well, you can do 2. All right, now I'll ask you what the difference between them is. Number 1, you can do this. My vector at 5. Okay. Number 2, you can do my vector dot at 5. Does anyone have any idea what the difference is here? They do the same, they kind of do the same thing. They kind of do the same thing. This one will return, it will return the element at index 5. They actually both return the element at index 5, but there's a distinct difference between them. They both return the element at index 5. All right, I'll give it to you. Are you ready? Returns an element at index 5 by reference. Returns a copy of element at index 5. Okay? This is return by reference. This is return a copy. So, let me tell you this then. Or let me ask you this. Let's say I wanted to do this. Which one works and which one doesn't? If I say my array at 1 equals 10. If I say my array at 1 equals 10. Which one of these is okay? So Giovanni asks, shallow or deep copy? You can always assume a deep copy. Not very many times in C++ will they allow a shallow copy to happen. All right. So Yang, Chef, and Top Wolf, you're all right. This one shouldn't work, okay? Because this is returning by copy. So this actually won't change anything in the array. All right. It won't change anything. But this one does. So if I want to go over it, I'll say for int I equals 0. I is less than my array dot size I plus plus. You can see out my array at I. Kate asks, when would you use at? It doesn't look too useful. Well, I'll tell you. We're going to be doing a player class today. So let's pretend I've got a private. I don't know. This is just, we're messing with stuff right now. Let's say this player has a vector of ints for some reason. Okay. And then you say public void foo constant. All right. Void foo constant. Now guess what? If I say cout v, I don't know, 0, this code will not compile. This code will not compile. Does anyone have any ideas why? This code will not compile. Now, it looks fine, right? Up front, it looks fine. All right, it looks fine, but what's going on there? Why do you think it might not compile? Size I plus plus cout my vec at I. Okay, Chef, yeah, we don't know if there's anything at v0. Let's assume there is. You know, if you want me to do this, I can do it. v.size is greater than 0. That's fine. But this code still won't compile. And I'll tell you why. This returns a reference. A reference. When we talk reference, we're talking about an address. It's kind of contiguous with address. This is an address. This returns an address to inside the object. And so C++ thinks this is unsafe. It says, hey, this function is constant. This function's constant. You are not allowed to make a reference to an address inside of this object. So back to your question, Cade, you say, why would you use this? Well, what if I need to access an element inside of it, inside of a constant function? That's when I say, hey, do not mutate this object. This code then will compile. Does it make sense? Did we learn something today? So inside of constant functions, you can't return references to addresses inside of the object. Rather, you're going to have to make a copy of it. Okay. For the most part, I think you just do this one. Of course, you can ask me questions if you need. All right. So those are vectors, okay? And that's all you need to know. As far as I know, all right? That's all you need to know. Are there any questions about vectors? If you want to look at the assignment just real quick, let me go look at it. Let me find it. Let's see here. Just in case I messed up, we're going to do that. And we're going to find where that is. We're going to find where that is. Okay. So you're going to have to do the... This is for fish. We're going to come back to it later, okay? So really, we're not going to go over the assignment right now because we have stuff to do, but I'm just going to show you. Look at this. Look at this. This is a 2D array of tank object pointers. Guess what? We went over that on Tuesday, right? So you know this, okay? So you're going to have to work with this thing, and then look at this. This is a vector of fish pointers, okay? So what does that look like? Well, you're going to have a fish pointer in there, and you're going to have a fish pointer in there. So if you're going to add fish pointers to it, right? If you're going to add fish pointers to it, you could say something like fish new pointer. This pointer might be null pointer or not. And then you can say something like fish list dot pushback. Now, obviously, I'm not in a function here. I'm inside of a class, so this code doesn't work, all right? Imagine somewhere in foo. Okay, somewhere in function foo, we type this code. We can say fish list pushback the new pointer. All right? Any questions on that? That's how you add fish to the vector. Yeah, so top wolf, at is a little different. All right, at is a little different. What you have to keep in mind is that these pointers are being stored somewhere in memory. So what at does is it returns a copy of the pointer, but you still have the address. So in some sense, at and your brackets might not make much of a difference in this assignment. Remember that pointers themselves have their own addresses. So if you're using brackets or at, you're returning a reference to where the pointer is stored or a copy to where the pointer is stored. Okay? So, that's that. All right, everybody? Now we're going to get back to virtuals today, all right? We're going to finish them up today. We're going to move, we'll move at a good pace here. There's not too much to talk about. We do have to get the notes down, and then we do have to do an example as best we can here. So let's just kind of speed through these notes as best we can so that you have them. And then we'll get to coding. All right, so remember from last class, when we were using virtuals, a class will always be involved. Chef asks, is abstract a keyword? No, it's not. I'll tell you about what that is in a moment. Patty's coming to say hello. Inheritance is also always used with function overrides. All right, so if we're doing virtuals, we have a class, we have inheritance, and we have function overrides. All three of these things are involved with virtuals. Now, there's always a pointer to the base class involved. There's always a pointer to the base class involved. I showed you that last class with the mammal, right? And the cat, and the whale, and the capybara. All right? This is going to be our only distraction for today. All right? Everyone can say hello to Miss Patty here. Yeah, everyone can say hello to Miss Patty's. And then she's going to get out of here. All right, so we kind of went on to this last time. All right, how do virtuals help us? Well, they help us achieve... I probably spelled that wrong. I before E, except after E. I don't know. Don't make fun of me. I'm a computer scientist. I was right. Everyone, please look away. Okay. They help us achieve something called runtime polymorphism. Now, polymorphism stands for something, all right? Does anyone have any ideas what that stands for? Polymorphism. What do I mean when I say polymorphism? You can give me a general answer. All right, you can give me a general answer if you'd like. But I am curious to see if you know what that stands for. Many, yeah, okay. I'm on board with it. My favorite answer is having many forms. Okay, yeah, Uchu, you're all correct, okay? But my favorite is having many forms. So there's a bunch of different types of polymorphism in C++. In C++, what polymorphism do we have? Well, we've got a few, right? We've got function overloading. All right, that's a function with the same name, but it has different bodies, right? Different forms, different parameter lists, right? So Chef says, changing the type of the pointer. Right, we're going to have a mammal that takes many forms. Inside of that mammal, it could be a whale, it could be a cat, it could be a capybara, right? That's what the polymorphism is talking about here. We've also got function overrides, all right? Those are also considered to be polymorphism. We also have virtuals, all right? And then we also have operator overloading. And we have templates. All right, these are all types of polymorphism that we have. Now, specifically, if you want to talk about these things, this is compile time, meaning that it will compile all of these forms before the program runs, all right? This is also compile time. But virtuals happens during the runtime. This happens during the runtime. Happens during the runtime. Okay? Why does it happen during the runtime? Well, pointers are allocated, right? Pointers are allocated during the runtime. So when we kind of talk about this stuff, we say, what form do you want me to have during the runtime? Okay. So that's why virtuals are considered to be runtime polymorphism. So, virtuals, we'll say this. Only functions and destructors can be virtual. Okay, only functions and destructors can be virtual. So the question is, what happens if function or detour f is virtual and it's called? Well, if the object associated with such function or destructor f is stored in a base pointer, all right? So we'll say if the object associated with f is stored in a pointer to a base class, the runtime will be able to call the correct override of f in the inherited class. Now that's a lot of words, all right? Let me kind of read through that again to make sure we're good. If the object associated with f is stored in a pointer to a base class, the runtime will be able to call the correct override of f in the inherited class. All right? So that's basically what virtuals do. All right? It's basically what virtuals do. So now we're going to get into the basics, all right? Now we're going to get into kind of just some lists here. Lists are my favorite thing, and we're going to talk about quite a few things. We're going to talk about basic virtual functions. Okay, that's on our list. The second thing on our list will be basic virtual destructors. Okay. The third thing on our list will be pure virtual functions. And then the last thing on our list will be pure virtual destructors. Okay, those are the only 4 things we're going to go over. They're all very similar with just a few things different. All right. Now, Chef and Synthos had asked earlier, what's an abstract class? Is that a keyword? Well, we'll say that. What is an abstract class? It is any class that contains at least one pure virtual detour or function. So that's what we talk about when we say is a class abstract. And that means that the class contains at least one pure virtual. All right, it can be the destructor, it could be a function, it could have multiple pure virtuals. But the only thing that matters is there's at least one pure virtual. So we'll get to that very shortly. So let's talk about our basic virtual functions. All right. Now, I think Geeks for Geeks does a great job of describing these things. All right. So I do give you some links here for that. That looks like that goes to the destructor. Oops. All right. So Geeks for Geeks is a great reference for this, in my opinion. So I'm going to give you those links. You can go look at them. So what is a basic virtual function? Well, it is a member function in a base class that has the keyword virtual in front of it. All right. Is a member function in a base class that has the keyword virtual in front of it. These functions are meant to be overridden in the derived class, all right? So any function or detour that is virtual is very likely, all right, not just likely, is very likely to be overridden in the derived class. You can almost expect that, right? Except last class in our capybara example, right, our make sound, patty.makesound, capybara.makesound, it wasn't overridden, right? So we kind of saw what happened there. We'll kind of touch on that in a moment. Now, the overridden function in the derived class does not have to be virtual, though it could be. All right, so let's get to our code here pretty much. All right, first I'll give you a little bit of syntax and then we're going to get to our code. All right, so syntax for any function is this here. I'm just going to do a copy paste. Virtual, whatever the type is, the function name, whatever parameters it takes, and then whatever code it has, all right? I should say this. Virtual functions always have bodies. So before we get into, say, our player example today, let's kind of take a step back. And let's go look at that mammal example we had the other day. All right, here we are. So recall we have the base class here, right? This is our base class. And then we have a derived class. We have another derived class, and we have another derived class. So I'm going to make you guys think here, all right? I'm going to need your participation. All right, it's time to participate. Let's kind of mess up this code here a little bit. Maybe not mess it up, but let's test some things. So the first thing I want to talk about is, obviously, this is our virtual function here, right? And so when we want to, say, call that make sound function, which is overridden in the derived classes, right? Notice that the virtual function in the base class happens to be overridden in the derived classes. All right, so we're expecting that whatever this function is, it will be called from a base pointer, right? A base pointer containing mammal, here it is. And we expect to call an overridden version of that function in the derived class. So for example, here we're going to call meow, right? We want the cat to make the meow sound. We want the whale to make the oo sound. And obviously this one's not overridden. So we're not going to see the capybara sound. Rather, we're going to see I'm a mammal. Now, someone had a great question last class. Might have been Synthos, but you can correct me if I'm wrong. Let's further derive a class from cat. What do you say? Class Patty derived from cat. All right. Now we're going to override this same function here. Make sound. Now Patty makes a very distinct meow sound. It's kind of like a, I don't know quite the way to do it, but it's like a meow, okay? So now we've got multiple derived classes, right? Patty is a cat, therefore Patty is also a mammal. Now notice here though, Patty is being derived from the cat class, directly from the cat class. And notice that this is not virtual here. Not virtual. This one is not virtual. And if I want to be even more specific though, it's this one that's not virtual, right? The cat one is not virtual. So when we come down here into Patty, what do you guys think we'll see? All right, give me a number 1 or a number 2. All right, number 1 for the regular meow. Number 2 for this kind of squealy meow. All right, that's number 2. Let's be number 1. What do you think we're going to see? All right, this mammal's going to get Patty. All right, and we're going to see either a regular meow or a squealy meow. Number 1 or number 2. So you guys are giving me a number 1 here. You guys are giving me a number 1, right? I think that makes sense logically. I think it makes sense logically. But we'll go check it out, all right? So we're expecting to see just a meow here. And I guess our reasoning is that this is not virtual, right? I'm assuming that... I'm assuming that because this one's not virtual, a lot of you are saying number 1. Now, Giovanni says number 2. We'll see. Now, Chef says, number 1, if we try to store Patty in the base class. Well, let's see. Let's see here. Let's go off to Bobby here. All right. It's mad at me for that. I guess because it's already assuming that this is a cat. So I'll take that out, I guess. Okay. So what we found is that most of you were incorrect about that. And that's fine because it is tricky. And let's explain it. We saw Patty's meow. This is Patty's meow. This is not the cat meow. And we say, hey, what the heck, man? This is not virtual. Why does it continue on like that? Well, you guys have to consider this. Every cat is a mammal. So in here we have a void mammal make sound. we also have the void cat make sound. So you're gonna get asked this question here. How many make sounds does the cat have? It has 2. It has 2 of them. And guess what? A cat is a mammal. And guess what? This is virtual. That's virtual. Does it make sense? So, kind of course, when we store Patty in this base class, it's a meow, right? Patty is also a mammal. So Patty can see this virtual stuff going on here. Patty can see this virtual stuff going on here. It knows that this is virtual. All right, so it just continues down the chain. It just continues down the chain. So any questions about that? That's a little bit tricky. Let's try this one. Let's try this one. All right, look at this one. This is a cat. You're not seeing it? Not seeing it? Well, let's see if we can come back around to it in a little bit. Can you get a paint diagram? Sure. Get a paint diagram. And save it from last time. That's a problem, huh? All right. What do we got here? It's going to be black. All right. That's our mammal class there. We're gonna skip the capybara, okay? Capybara is not coming along on this one. Sorry about that, folks. And just to save time, we're gonna kind of use this crummy little arrow. All right. So what do we got in here, huh? What do we got in here? Well, this is a mammal. Make this, that's a good size. I think you can see it. This is cat, and this is Patty. This is a whale. So, this is our kind of inheritance diagram. And you notice that this is like a chain, all right? This is like a chain. Whenever I say the inheritance chain, I'm talking about this. Talking about this. So up here we've got a virtual make sound, all right? And we've got a make sound. And we've got a make sound. Also in here we've got a make sound. All right. So, if you're considering this pointer, this base pointer that we have, where is it? Here it is. Mammal base pointer. It's looking at a mammal, all right? Guess what? It's a base pointer, right? So virtual alert, we're talking about virtuals. We're also talking about this one in particular, right? The make sound function is virtual. We know this, right? I've specified it here. Let's get a little... Whoa. Something going on here. It's virtual. You can see that, right? So, we come to our code down here. Now, look, we put Patty in this base pointer, all right? Now, guess what? Cats are mammals. Patties are cats. Therefore, by the transitive property, patties are mammals. Okay? Patties are mammals. So, whoops, wrong one, folks, wrong one. This one. Emma says, so once the virtual is referenced to make sound in mammal, it will remain virtual throughout the rest of the, I would say, the inheritance chain. Yes, we'll put that in the notes. It will remain virtual throughout the rest of that inheritance chain. We'll even see that here. But recall that this is a mammal, right? This is a mammal pointer here. Mammal. And on this side, we've got a patty. All right, we call make sound. So what does it do? It goes up here to mammal. It references. It says this is virtual. And so then it kind of comes down here. And it says, hey, now we're at the cat. You say, hey, is Patty a cat? Yeah, but we're not at the class that I want to be at, right? Look at this. We said this is a new Patty. So it says, hey, am I at Patty yet? No, I'm not in Patty. I'm going to keep going. So then it comes down here and it says, is this Patty? Yes, I'm Patty. I will now make the sound. Does that help? While we're at it, let's see. We're going to test this one, all right? What happens here? What happens here? Now this cat, this is a cat base pointer, okay? This is a cat, not a mammal. This is not a mammal. All right? This is not a mammal. So if we reference the cat as the base class, do we see that it's virtual? Nope, it's not virtual. So give me a 1 or a 2. What do you think we see? Number 1, number 2. Now remember, you got tricked last time. So let's use our brain. Let's do our best to use our critical thinking skills here. Notice that cat is the base class, all right? Not mammal, cat is the base class. We've got some votes for 1. We've got some votes for the regular meow, huh? Okay. Let's go take a peek. Did I save it? No, I didn't save it. All right. Moment of truth. Someone make a prediction. I'm just kidding. You guys are in shambles. Again, you have been, your mind, it doesn't work anymore, right? You're going to go to bed tonight. You're going to have nightmares about this. Why? Why did that happen? Does it make sense? Guys, it does make sense. It's in here. Guys, look. It's in here. Guys, it's there. It's there. Yes, Fuzzy says cat class is a mammal, which still has a virtual. Yes. It's there. Look at it. It's there. It's hidden, right? But you can do this. I'm allowed to come in here and say, mammal, make sound. I'm 100% allowed to do that. Guess what? In Patty class, I can do that. Mammal, make sound. I gotta put the extra colon there. Okay? Patty can see it. All right? The cat can see it. The cat here, where is it? The cat, it can see that virtual. It's kind of, in some sense, all right? Here's kind of the paint diagram you need to consider. I bamboozled you again, right? You guys are mad at me. But hidden up here in the clouds, right? We've got a mammal make sound. We've got a virtual mammal make sound. Kind of up here in the cloud. It's up here in the cloud. We'll even make a little pretty cloud for it. That's terrible. Let's make a pretty little cloud for it. What do you say? Where's the pencil? Give me the pencil. Here it is. All right. It's up here in the cloud. All right. So as long as there's a virtual somewhere in the chain, all the derived classes will be, or that function will take a virtual path. Chef says, even if we start with a base pointer to a cat, it still has access to the fact that the cat was derived from a mammal. Yes. And the most important part is that that's the function override we're talking about. Specifically, it's make sound. They're all spelled identically. Okay? So just because we've got this virtual mammal make sound up here in the cloud, it's still considered as a virtual function. So, are we okay with that? You're Brandon too? You might need to rewatch the video. That's fine. But you should have a general idea what's going on now. Okay? You should have a general idea what's going on. So now, we're going to spend our time kind of doing some more notes, all right, just to get the other stuff down. But pretty much you've learned it, all right? Pretty much you've learned it. Hannah says, will there be a time that we can unvirtual something after calling virtual? I'm not sure. You might be welcome to, say, specify it. I might be able to do this. I might be able to do that. Let's see. You want to check it out? I think we should. I might be able to do that. Honestly, I'm not sure. Hold on a sec. I left this. That would have been a problem. Yeah, so I can kind of unvirtual it if I want to. But I have to explicitly say what class I want you to reference. Okay? So, yeah, I hope that answers your question. I'm not quite sure if I understood it, but you can force it if you want to. You could force it. So that's that. So, Fuzzy, yeah, I'm glad it's making some sense, right? We're understanding it a little bit. It's kind of fun. So let's do our notes, all right? Let's go to our notes, and let's just kind of talk about these things. Okay. So you learned what it means for something to be virtual. So guess what? All of these things here that are virtual kind of take the same idea, all right? So you've learned how it works. The rest of this stuff should be easy peasy. Fuzzy says, so is it a good idea when making a derived class to make the base class functions virtual? So here's my question to you. Check this out. Check this out. Think back to assignment 3. Can everyone think back to assignment 3 for a moment? Well, we have an int HP, maybe a strength, maybe a skill. Yeah, we'll keep it basic, right? And there's like a weapon, right? Let's just pretend I'm using a string in this case. And then you have some stuff here, right? You've got some, I don't know, you've got a void do damage function. And the do damage function takes a player, right? Do damage function takes a player. And then you've got the take damage thing, right? Which we're not going to get into it. So then you have a bunch of classes. Class red player, which is deriving publicly from the player class. Then you've got the blue player and the green player, right? And the overridden function from this assignment was this one. Now, if you look in main, all right, if you look in the main of that function or of that program, you'll see here, I'll make a little vector code for you guys so you can reference it. But I'm going to use this one instead. I'll make a little vector code for you, though. If you look in there, you've got something like red player, you know, R, I don't know. And then you've got the blue player and the green player. RGB. And if you see what they're doing, you say R.doDamage, and then you pass in, say, G. Okay? You pass in, say, G. Now, the only reason it knows to call the red player do damage is because you're saying r.do damage. But you could completely revamp this code. You could make this a virtual. You could make that a virtual. Now you're going to want to make these at pointers, by the way. The moment you make that virtual, you want to be passing around the pointer. Okay. And then when you're in here, you say, you know what? I don't want a red player. I just want a base player. R equals new red player. Okay. Do you guys kind of see what's going on here? You can completely revamp assignment 3 code if you want to. And you can make this virtual. And then instead of having to specify, this is a red player, this is a blue player, you're going to let the runtime figure it out on its own. So when you say, I don't know why I was mad. When you say r.do damage, sure, it's going to reference this player class, but then it's going to go down the chain of inheritance. It will automatically find which one we're talking about. And then it will automatically do double damage to green players. Does it make sense? I don't know. I kind of went off on a tangent there, Fuzzy, but I'm just trying to explain that it depends on how you want your code to work. So your question is, when making derived class to make base class functions virtual? Not always. It depends what you're doing. In terms of all video games you've ever played, I guarantee that they're doing virtuals. League of Legends, Overwatch, maybe even RuneScape. All that stuff is using virtual functions. I 100% guarantee it. Okay? So it just depends. What is the code doing? Do you expect to say, hey, I've got a League of Legends game. We're going to have 10 players. Are they all going to play, you know, Malphite? No, they're each going to play a different character. So do you want to have all these if statements that says if, you know, Malphite, you know, sorry, I'm going off on a tangent, is attacking Annie. And then in here you've got some special code. And you say, all right, that's, I don't know, what are we talking about here? Combination, right? We've got 120 champions. That's 120 times 120 possible attacking combinations. So it looks like you're going to need some 1,000 more if statements here. I don't know. If Malphite is attacking Bard. Oh, that's my next if statement. Better keep going, right? I'm not done yet. I've got 1,000 to go. What if I can just replace that with a virtual? This is so powerful. This virtual function is so powerful. It's going to take this and it's going to cover 1,000 different cases. Okay. Was my tangent confusing? Did I scare you? I hope not. I hope you kind of understand what this does, right? Don't need a bunch of if statements anymore. You can just make things virtual. Okay? All right, so let's get to this stuff. So let's talk about virtual destructors. For the most part, this is the same as a virtual function, except it's a destructor. Okay? Why would we do this? We need to specify which destructor gets called. Okay? You guys making me smile right now. I do hope that was helpful. This is what virtuals are for, quite literally. Obviously, I'm doing this in the wrong thing here. Whoops. This is what virtuals are for. Literally, gaming is virtuals, but it applies to a million other things, okay? Yeah. Thanks, Chef. Sorry about that. So, why do we do this? Well, we need to specify which destructor is called first. Okay? So, we've only got 10 minutes here. I'm just saying it out loud. Let me just kind of make a point to you. Say I put mammal here. Mammal. Time to... so, we've got a destructor here, right? Goodbye, mammal. And say we got a bunch of other destructors in here. We're just going to work with the cat for now, all right? We're going to work with the cat, and we'll work with Patty. That's all I really care about right now. I'm getting ahead of myself here. So as of right now, let's pretend like we don't have any of this stuff. Then we'll base pointer. We'll do the cat. And then we'll do the Patty. So as of right now, all right, as of right now, we've got just this regular destructor, right? So guess what? When I call delete, destructor gets called here, right? Detour is called. We're only going to see one message. What is the message here? We're deleting a cat here. Are we going to say goodbye mammal, goodbye cat? What do you think? 1 or 2? 1 is the mammal, 2 is the cat. 1 or 2? Same thing here. Detour is called. Let's see, 1, a 2, or a 3. Right, what are we going to see here specifically? When the destructor is called, we're going to see goodbye mammal, right? Why? You know that because it's not virtual. It's not virtual. It's not virtual. Goodbye mammal, goodbye mammal, goodbye mammal. It's not virtual. So we say, hey, I'm going to need you to call that destructor, okay? I'm going to need you to call that destructor first. I'm going to need you to call it first, okay? So you make it virtual. Next thing you know, goodbye cat, and then goodbye mammal. Why does that happen? Can anyone remind me? Why does that happen? I've made a mistake here, folks. Let me fix it. Can someone tell me, why does that happen? Why does that happen? Goodbye cat, goodbye mammal. Goodbye Patty, goodbye cat, goodbye mammal. Goodbye Patty, goodbye cat, goodbye mammal. Why does that happen? Why is it now that? You guys know that. Yeah. So Chef kind of says it there, right? The every cat is a mammal. Every Patty is a cat is a mammal, right? So almost always, not almost always, always will you call the derived most destructor first, and then the next one, and then the base, right? That's why that's happening. So that's what the destructor does. Now, alert, everybody. Alert. Test question alert. What is the most important case that our destructor should be virtual? What's the most important case I need to reword that. But what is the most important case that our destructor should be virtual? Answer. The derived class contains a pointer. Okay? So let's pretend like that happens. All right? Up here, Patty's got, hey Patty, I've got a pointer. Int my pointer. Let's say this gets allocated. Now that pointer contains memory. If this is not virtual, that pointer does not get deallocated, right? Assuming that this destructor is going to go, hey, if pointer does not equal null pointer, delete pointer, right? assuming the cat destructor is what takes care of that, if this destructor is not virtual, you now have a memory leak. Does that make sense? Test question alert. What is the most important case that our destructor should be virtual? The derived class contains a pointer. Okay? That's the most important case. All right? If I'll also accept this. The derived detour needs to be called first. All right? I'll accept that too. I'll accept that too. You know, if you want to be general about it, that's fine. But most importantly, you're crying, why does my program have memory leaks? Well, was your destructor virtual? All right, so now we're going to talk about these two things real quick. Okay. I don't know if we'll get to doing an example of them, but it's really not a huge deal. You'll get to practice them anyway. They really don't change much. Okay. So a pure virtual function. All right. Pure virtual function. It's the same thing as a virtual function. But it has no body. It has no code. What does this mean? Officially, let's do it. I'm going to make this thing a pure virtual function. Guess we'll put the syntax in there. I'm warning you, we might go 3 minutes over, but we need to do this, okay? I'll try to just keep it moving here. What does this mean? Chef says all the derived classes have to define that function. I think so, yes. It also means that the class containing the function cannot be instantiated. Perhaps, Synthos. I'll need to go over that with you at some... I'll take a look at the end of class if you want to hang around. But it means that the class containing the function cannot be instantiated. And the reason for that is, say, I'm going to say declare my mammal, and then I'm going to try to call make sound. It's going to say I'm a generic mammal. I don't have code for this. It becomes an abstract class. All right, so if you didn't kind of get it, now you do. Abstract classes cannot be instantiated. Okay, so if you want to take that into, notice that this is now pure virtual. I'll put that in the notes. I kind of skipped over that. But you'll notice that if I tried to declare a mammal somewhere, you'll see that the code will cry. It will say, hey, I'm not going to let you compile. It says, hey, cannot declare variable base to be abstract type mammal. The virtual functions are pure within mammal. Make sound is a pure virtual function. Okay? So, just kind of speeding ahead. Come talk to me if you need to talk about it. But, a pure virtual function makes an abstract class. Abstract classes cannot be instantiated. What's a good example of something that's abstract? A shape. What shape does a shape have? I don't know. Can you describe the shape of a generic shape to me? No. So that class should probably be abstract, right? Can you describe to me the generic shape of a mammal? Maybe. Probably the class should be abstract. Right? You're not supposed to declare a shape. It's just supposed to be there, like a blueprint. All right? So that's virtual type func name params equals 0. Okay? Pure virtual destructor, exact same thing, all right? This is the last bit. Hang with me. I know we're going a little bit over, but we're right there. All right, we're here. We've made it. Same thing as a virtual destructor, except it makes the class abstract. Okay? Now there's something a little different about this. All pure virtual detours must have a body. Why? Because the destructor is always called. Why? The base detour is always called. All right? You're always going to destruct the mammal. You're always going to destruct it. So pure virtual destructors must have a body. So if you're going to declare this in the class, you say, hey, class name, virtual. Virtual, class name equals 0. And then outside of the class, you give it a body. I don't think you need to include the virtual. You might. I don't think so. I'll try to compile it, but that's that. Class name, body. Make sense? So we went 2 minutes over. I'm sorry about that, but we got through it, all right? You're welcome to hang out with me real quick. I'm just going to give mammal here a pure virtual destructor. And compile it. I'll upload this code, and that's that. You're welcome to go unless you'd like to watch me do this real quick. If you have any questions, hang out with me. Ask them if you'd like. Otherwise, you're free to go. All right, so that should compile. So mammal is now abstract class. So we can't instantiate it, but we can still make sure that the destructor has a body. Okay. Why? Remember, mammal destructor is always called. It's always called. So even though it's pure virtual, it has a body. And that's how you do that. So, unfortunately, I can't go over the assignment. Maybe talk to Angelica in office hours. Come talk to me in office hours if you'd like. I'll go over it with you. Synthos, if you've got some time, I'll go look at that wallfish maybe. But otherwise, you're free to go. I'm going to hang out here and just kind of pull up that assignment real quick to see if I can answer some questions. But if you're going to head out of here, best of luck to you. I hope you have a great weekend, a great day. Ask me questions if you need. Okay? Let's see here. Wallfish. Yeah, look at that. The wallfish has got it's got a virtual in there. Yeah, I'm glad you learned a lot. Have a great day, guys. I'm sure you're welcome. Chef, have a great day. Kane, CS2O student. Giovanni, you guys have a great day. Have a great weekend. Synthos, if you're still here, I don't think so. Back to your original question, I think you were asking about pure virtuals on the wallfish. Truth is, I think your wallfish, it's going to have this function. It's required, but it won't do anything. All right, so it's not a pure virtual. It won't do anything. It needs to be overridden, but it just won't do anything. So I hope that kind of answers that question. Okay, it's just not going to do anything. Yang, you're welcome. Have a great weekend, Turbo. I'll see you later. And Synthos, if you need me, just send me a message, okay? We'll work this out. Yeah, 99% sure it's just not going to do anything. The virtual part probably happens up here. Notice here the pure virtuals, they exist in the tank object. Well, Synthos, it will have a body. The body will likely be empty. It will just be an empty body. You need to give it a body to indicate that it has some functionality, and that function is that it does nothing. These pure virtuals exist up here. And if you don't override it, you'll see that the wallfish will become abstract because it doesn't have a version of this. So yeah. So try it out like that. Just make sure it does nothing and you should be good. I'm going to go ahead and end the stream here. You can always message me if you need. And I will see you later. Have a great weekend, Synthos. And anyone else who decided to hang out.